In the name of Almighty Allah, the most merciful and the most beneficent. Well, students, I am Habibur Rahman, your physics teacher. Welcome you all in this session 2 of week 2. The previous session, as you all know, that we discussed about physics, the branches of physics and physical quantities. In this session, students, we will discuss about the prefixes, scientific notation, and two of the measuring instruments, that is meter rule and measuring tape. As you all know that in the previous session we discussed in detail about the branches of physics, why it is important for us to study physics, why it is important for us to discuss about physics and the role of physics, and then we discuss about physical quantities and its types. In this session, as you all know that these topics are very much important to study physics in detail. These are the basic concepts which we must know about these topics. So that is why I will focus on these topics in a very minute way. First of all, come to prefixes. Students, according to the definition, prefixes are basically the words or letters which we add before SI unit. The words or letters added before SI unit. First of all, I want to tell you people that in the previous session we discussed about units, that is base units and derived units. Means here I want to give you some examples, like kilogram is a unit of mass, second is a unit of time, Kelvin, K, is the unit for temperature, meters is a unit for length, meter per second is a unit for speed or velocity. So these are some of the examples of units. And in the session of week 1, you can also see the tables in the video of different quantities. You can see the units of those quantities as well. So I will not go into the detail of units in this. Just I will focus about prefixes. So prefixes are the word. Pre means before. Pre means before. And fix means which we want, the thing which we fix before some specific letter or word. So that is why prefixes are the words or letters added before SI unit. So here are some of the examples of prefixes. You can see kilo, mega, giga, milli, micro, pico. Keep this thing in your mind that every word, every letter you can see in this here, exa, peta, tera, giga, mega, these are the prefixes. Here these are also the examples of prefixes. So every word has some specific value, and we call these values as multiples or multiplication factors. Let's suppose the value for exa is 10 raised to power 18. The value for peta is 10 raised to power 15. Every word has some specific value. It is understood. It is already it has been already discussed and finalized by the scientists and the physicians. Giga 10 raised to power 9, kilo 10 raised to power 3, deca 10 raised to power 1. Here comes pico 10 raised to power minus 12. Every prefix has its own specific value. So whenever people want to fix some prefix before any SI unit, then you have to learn these values along with the prefix name and along with their symbols. So this whole table which you can see here, this one, you must have to learn this table. This portion which I am going to circle it now, this one, it is not compulsory or it will not be beneficial for you people in so much good manner but the values of the prefixes, this one, and the symbols, they are very much important. So please, after learning the definition of these prefixes, you must have to learn this table, which also be given on your book, physics book of class 9, page number 7. You can see the table 1.3. It is very much important for learning of prefixes. Okay, the second thing is why we use prefixes. We must have to use prefixes to express bigger values in a very comprehensive way, or to express smaller quantities in a very comprehensive way. In the next slide, you will be able to convert the bigger values into smaller values, or smaller values into a very comfortable or comprehensive way by using prefixes. And very important note you are watching over here, that we cannot use two prefixes at the same time. This is very much important. Like, you cannot use, if you want to write let's suppose 1000 meters. Okay, so when you will convert this 1000 by using prefixes, then you are not allowed to write two prefixes at the same time. Let's suppose you people will not be able to write mega kilometers or giga kilometers or micro kilometers or hectodecameters. You people must and only have to write one prefix at a time. You cannot use two prefixes at the same time. So this is the main rule. You must have to keep this thing in your mind. Now come to some of the examples. Here I will discuss that how you can change or write the bigger values by using prefixes and smaller values or quantities by using prefixes. Here you can see this one is the bigger value, 200,000 grams. G is given, that is unit is given, but there is no any prefix here. Hertz, unit is given, but there is no any prefix. Unit is given, there is no any prefix here. Grams, which is the unit, in third example you can see G, that is grams, is given, that is a unit for mass, but no any prefix you can see here. Here in the fourth example you can see meters is given, is written, but there is no any prefix here. So in all these four examples we will learn that how we can use or we can write the larger quantities in a comfortable way by using prefixes. First of all, come to first example, that is 200,000. Boys, very packed rule and very easy rule for writing the bigger or smaller quantities in a comprehensive or precise way is, keep this thing and this point in your mind, that whenever you want to shift the decimal point in the backward direction, then the power of 10 will always be positive. Whenever, again I am repeating, whenever you will shift the decimal point in the backward direction, then the power of 10 will always be positive. Just this thing, focus on this thing. Decimal point, when you will shift the decimal point in the backward direction, the power will be positive. And here, when you will shift the decimal point in the forward direction, this third part I want to show you people, that whenever you want to shift this decimal point in the forward direction, the power will always be in negative. Can you see? Again, in the fourth example you can see if you will shift this decimal point in the forward direction, the power will always be negative. So when you will shift decimal point in the backward direction, power will always be positive. And when you will shift this decimal point in the forward direction, the power will be negative. Backward means power will become positive, and the forward shifting means the power will become negative. This is the first rule. Now come to the second rule, that how you people will come to know that how many digits we have to shift this decimal point. So it is up to you that how many digits you have to shift. It depends upon the prefixes which are given in the like you can see in the previous slide that in the table the values of specific prefixes are given. So if you want to convert or to use a prefix kilo, means 10 raised to power 3, then you have to shift 3 digits. If you want to use a prefix deci, then you have to shift 1 digit. If you want to use tera, then you have to shift 12 digits. So in the previous slide you can see that table is given, so it depends upon you which prefix you want to use. Like here I want to use kilo, k, in the last step of this first, you can see. So in the question you can see 200,000 is given. You cannot see any decimal point in this. So this is another point. Whenever there is no any decimal point, please students, this means decimal point is in the end. So that is why I put here. And now you want, first of all you will put this decimal point so that you people will become easy to shift the decimal point in some specific direction and to jump some specific digits. So here I want to use the prefix kilo, so I will shift this decimal point 3 digits backward, because kilo means 10 raised to power 3. So when I shift this decimal point in 3 digits backward, this means this will become 200.000 into 10 raised to power 3. When I shift this decimal point here, then I will write 10 raised to power 3, because 3 digits backward shifting means 10 raised to power 3. If I shift this 3 digits forward like this, here in example 3 you can see 3 digits back forward, here I put this decimal point here, it will become 0.02 and the power will become -3 because I am moving forward. So in place of this 10 raised to power 3 I put kilo, because the value of kilo is 10 raised to power 3, so I use the prefix instead of using its value. So the value 10 raised to power 3 means kilo, so I am putting kilo for 10 raised to power 3 along with the SI unit, that is grams. So by using prefixes we will be able to write 200,000 grams into a very precise numeric value, that is 200 kilograms. I hope you understand the concept. Now come to this. Here you can see 1 2 3 4 5 6 7 8 9 10 digits are here. So it is very uncomfortable for us to write 10 digits again and again in every step, in every wherever we want to write this digit. It is very uncomfortable for us. So by using prefixes we will be able to write this bigger value in a very small, into very small digits by using prefixes. So here there is no any decimal point, you cannot see any decimal point, this means the decimal point is the end. For writing this large digit into smaller digit, I will shift this decimal point. Here I am shifting 3 digits backward. If I am shifting 3 digits backward, this means 10 raised to power 6 digits backward, this means 10 raised to power 6. So here you can see in this step 3300.000000 into 10 raised to power 6 hertz. Here the answer 10 raised to power 6 is the value for mega, and the symbol for mega is capital M, 3300 megahertz. Again the third, here if I shift this decimal point in the backward direction, then this digit will become more bigger. I want to make it precise, so I will shift the decimal point in the forward direction. I am going to shift it 3 digits forward. If I shift 3 digits forward, the power will become 10 raised to power minus 3. So 10 raised to power minus 3, the value for it is milli, and the symbol for milli is small m. So 0.02 milligrams is a very precise digit for writing 0.00002 grams. Again, in this fourth example, you people can easily judge why I write minus 10 raised to power minus 2 and why I write C, that is the symbol for centi. The centi value is 10 raised to power minus 2, so I put the prefix C instead of 10 raised to power minus 2. I hope you are well clear about prefixes, how you will write bigger values or smaller values in a very minute way. Now come to the scientific notations. Students, the other name for scientific notation is standard form. Here we will learn and we will discuss that what is scientific notation and what is standard form. Before going into the detail of definition, before going into the learning of definition, I want to clear one thing, that in standard form or in scientific notation, keep this thing in your mind that decimal point must be after first non-zero digit. After first non-zero digit, decimal point is must. But if you are writing the decimal point after 2 digits like this, like in this, if you are writing decimal point after 3 digits, then this will be a notation, but this will not be a scientific notation. This is correct, but these two notations are not scientific, because in scientific notation or in standard form, it is very much compulsory that the decimal point must be after first non-zero digit. Here you can see an example. It is 75,820. Here there is no any decimal point. This means the decimal point is in the end, which is understood. If you people will shift this ending decimal point 3 digits backward, that is between 5 and 8 like this, you are shifting decimal point 3 digits backward, this means the power of 10 will become 3. And if you are shifting 2 digits backward between 8 and 2, this means the power of 10 will become 2. These are the notations. These are correct. You can write 7580, 820 in these two forms. But this is not a scientific notation, students. This is not a standard form. As you all know, I told you before, the standard form is that notation in which the decimal point is after first non-zero digit. Here you can see the decimal point is after first non-zero digit. So this is a scientific notation, or you can say this is a standard form. 7.5820 into 10 raised to power 4 is the scientific notation of this 75,820. I hope now you are clear about scientific notation. Now you come up to the definition of scientific notation. In scientific notation, a number is expressed. Number means 75,820. It is going to be expressed if you want to express it in scientific notation. In scientific notation, the number is expressed as some power of 10. As some power of 10 multiplied by a number between 1 and 10. So if there is any number which is between 1 and 10 and that number is going to multiply with some power of 10, then that whole complete expression will be called a scientific notation. Here you can see 7.5820 is a number between 1 and 10. And 10 raised to power 4 is the power of 10, you can see. So when these two ingredients will get multiplied like this, then you can say that this whole notation is called scientific notation. I hope now you understand about scientific notation, and this is the standard form. And you can say that in standard form, the standard place for a decimal point is after first non-zero digit. Now come to the measuring instruments. In the first chapter of physics book class 9, there are so many instruments which we will discuss, but now we are going to discuss just two measuring instruments, that is meter rule and the measuring tape. First of all, come to meter rule. In this picture you can see the meter rule here, and this is a length measuring instrument and it is commonly used in laboratories. It is always 1 meter long, that is why it is called meter rule. Here you can see the ending digit is 100. This is basically a scale of centimeters, and this is the upper scale. This upper scale is of centimeters and this lower scale is of inches, but we are concerned with this centimeter here. 1 meter means 100 centimeter. 1 meter means 100 centimeter. So 1 meter contains 100 divisions or parts, and each part is equal to 1 centimeter. Here in this scale you can see this is also you can say a picture of a meter rule. I cut it and paste it here. Here you can see that from 0 to 1 there are 10 divisions, and each division is equals to 1 millimeter, and that is my second last point, that 1 centimeter, that is from 0 to 1 centimeter contains 10 parts. You can see here from 0 to 1 this is 1 centimeter, and 1 centimeter contains 10 parts, and each part is equals to 1 millimeter. This one part is equals to 1 millimeter. And how many divisions on 1 meter rule complete scale? 100 divisions. And 100 division means, and each division is equals to 1 centimeter, and in 1 centimeter there are 10 divisions, and each division is equals to 1 millimeter. So this means the smallest reading which we can take from a meter rule is 1 millimeter. The smallest reading which we can take from a meter rule is 1 millimeter. So for this reason we can say that the least count is 1 millimeter for meter rule. The least count of meter rule is 1 millimeter. What is least count means? The smallest reading which an instrument can measure is called least count of that instrument. So in meter rule we can measure the smallest reading which we can take by using meter rule is 1 millimeter. So 1 millimeter is the least count of a meter rule. Now come to the measuring tape. Measuring tape is same like you can say a meter rule. It is also a length measuring instrument and consists of thin and long strip of cotton, metal or plastic. You can see in the pictures. Generally it is 10 meter long, 20 meter long, 50 meters long or 100 meters long and more than that. But more generally the lengths of measuring tapes are 10, 20, 50 or 100 meters. And again the least count for measuring tape is 1 millimeter. That's all from me side. Thank you so very much for your patience and for your listening.